Good morning, I'm Cody Henriksen. Today we're going to take a look at Java and 2D arrays, aka the two-dimensional data structure. So when we're looking at a 2D array, we're looking at a 2D structure like say for example, a checkerboard or an egg carton, a way we can actually hold information using rows and columns to talk about this. When we're talking about this, we also want to make sure we're using the idea of rows and columns and not Cartesian coordinates. Don't look at X and Y because the logic is not going to make the same sense. When we're talking about this, we have the organized in that 2D grid or matrix. And in Java, what we really have right here is an array of arrays because each row in the 2D array is its own data structure because it's an array, the column 0, that holds each row at a time. So it's an array of arrays. Two sets of square brackets are the quote keyword because again, Java is pretty hipster when it comes to arrays. It doesn't actually have a keyword for it, it just has square brackets to designate that it's an array. So just keep that in mind. It doesn't have a keyword for it, so it's not a keyword-based type you'd have to look for like, oh yeah, that's what I'm looking for. The type or type, lowercase t or capital T, because it can hold either primitives or objects. Arrays are the one data structure in Java that can hold either kind of value, so that's a nice little feature about it. And then square bracket, variable named indicates a 2D array, and then equals new type again, then the number of rows, then the number of columns. Those are the English way we count, or the human style of counting, where we start with 1 for those rows and columns value. And we want to make sure we keep in mind that the rows are always that first set of square brackets, the columns are the second set when we're keeping that in mind for our logic. So rows first, then columns. That's not talking about traversals, that's talking about the actual what address we're looking for. So here we see the actual addresses of a 2D array. This is a 2D array of 4 by 5. So we start off at 0, 0 in the top left corner, and as we go down each row, it increments by 1. So we have 0, 0, and then 1, 0, and then 2, 0, and then 3, 0 again, because the first value square bracket is the row, the second square bracket is the column. These are all in column 0, so they also have 0 all the way down. This row all the way across has row 1 as the first value, and then it goes 0, 1, 2, 3, 4 for each of the values indicating the column. The last spot in the 2D array is sub 3, sub 4, because it has 4 rows and 5 columns, but we always subtract 1 from each of those values. We start counting at 0 to actually access that spot. So that's where we can see the actual structure of that, so we can see how we deal with the 2D array, look at the addresses using that structure. For 2D info, when we're talking about a 2D array, when we're working with that, we want to keep in mind the placement of the equal sign to see what we're doing with that 2D array. If the equal sign, aka the assignment operator, is on the right of the array name and the address, aka the row and column square brackets, then we're assigning a value into that location. So if the equal sign is over here on the right, we're shoving it in. However, if the equal sign is over here on the left, I'm retrieving the value from the 2D array and giving it to a variable or some other thing. If it doesn't have a square bracket itself, I'm just retrieving the value out of it and using it as a parameter or something like that. So that's all we have to do with that. So that's, if it's left or if it doesn't exist, we're just retrieving the value. So we have the amazing sub-0, I know, cheesy, but sub-0.length is for our columns. So we have a reference right here to the Mortal Kombat character Sub-Zero, and when they're making their magic ice ball attack, they're referencing the fact that we have Sub-Zero equals dot length for columns, and so COL, cold, columns, Sub-Zero is cold. I know, it's cheesy, but it's a great way to keep that in mind. When we're talking about 2D array initialization, we have two ways of doing initialization. The default way is to initialize it using this idea equals new whatever type, square bracket rows, square bracket columns, and that'll fill it up with a default value. For all primitive values, that's 0, except for Boolean because that's false. And for every single object type, that's all nulls. Not exactly the most useful, but it's there, so we want to keep that in mind. We can also, however, initialize a 2D array with the values separated by commas using sets of squigs around them so we can indicate the actual structure that goes with that. And we'll see a quick example of that over here on the next slide. So we already have the 2D initialization demo. So we have a private void two-dimensional demo, and we have int 2D array grid as a new int 2D array of 4 rows and 5 columns, aka 20 zeros. And so when I do that right here, I have just a lovely 2D grid right here where I have 20 zeros filling up because it's an int, so it automatically fills it with the predefined value of 0 for every single spot inside that 2D array. Then we have our debug duck 2D array called boring array, and it's a new debug duck array of 4 by 4, so 4 rows and 4 columns, and so it's 16 null values. Boring, that's not exactly useful. We don't have cute little debug ducks like this that can actually do something for us. It just fills it with all null values. So we have to make sure when we initialize a 2D array, we have to go through it after we initialize the array, we have to go through and assign values to each spot inside that 2D array if we want to actually use something inside that. Otherwise, we get 16 null values or 25 null values or 43 null values, whatever multiplication process we're doing for rows times columns to get that. So we want to make sure that we actually create something that's useful and helpful for creating the amount of rows. Otherwise, we just get nulls, and that's not very helpful. We also have the other way of doing it where we can initialize it with predefined values. In this case, I'm using some string literals in words. So string 2D array words is equal to, and I'm using my vertically aligned squiggle so I can indicate that, oh, here's where I'm going. And then I have these words are my first row, second row in a 2D, and then third row, array of string. So each row has 3 values. I have 3 rows, so I have a 3x3 grid on this. And if I put that together right here, string array words equals, and then these words are in a 2D array of strings. So you can see that structure we're doing to actually hold those values. And so when we're talking about working with that, we're putting together those words in that 2D array reference, and so we can actually access all those values by referring to the structure of that 2D array, starting at row 0, column 0, and work our way to row.sub0.length or row.length -1 and row sub0.length -1 as well to get the column values for each of those things. To iterate over a 2D array, the most effective and common way to do so is with a standard for loop. This is one we use all the time. We're using a nested set of for loops to do so. The proper iteration can be done either in row major order or column major order. If you've heard the phrase row major or column major order, it means which one am I doing first? Am I doing the rows first or am I doing the columns first? This doesn't change anything about the way the square brackets are actually handled, but rather do I want to loop over rows first or columns first? Most of the time, I myself use row major order. However, sometimes column major order is a great way to do it. And so it depends on the logic of the problem you're looking at. Take a look at the code you're working with, what you're trying to solve, and that would tell you what you want to do with that. So that's what your outer loop is the row major order or column major order. Your inner loop is the next one that you'd handle. Now you can theoretically write a for loop that'll go over the entire 2D array without having a nested loop, but it requires ridiculous manipulation, modulo divide structure, and we don't want to take the logic to do that because you still have to process every single value, and using 2 separate loops to handle it actually makes your logic so much easier. So use 2 loops or 3 loops if you're doing some complicated stuff. It makes life a better space. Now, if you need addresses, aka you want to actually assign values, you need to use a standard for loop, because if you want to actually talk to the value itself that's stored inside that spot of the array at that row column intersection, you need the address, aka the standard for loop, where you loop over the rows and columns to get that location. And this is especially when you're assigning data or replacing values. You can also use a standard for loop to iterate over only parts of a 2D array. And this is really helpful if you're doing some fun things, like say, I only want to work in the bottom section of the grid, or I want to work only in the middle of the grid, or I only want to work on the even rows, or I only want to work on the odd columns. And so you can do some really cool stuff by working with that, by manipulating your 2D array so you only look at certain spots in that, and that's only possible with a standard for loop and using nested iteration with that. Let's take a look at some examples of this. Now these are both row major order examples. They're really quick and simple. For int row is equal to 0, row is less than grid.length and row plus plus. Inside that we have our nested column because we're doing row major order, so columns next. For int col is equal to 0, col is less than grid sub 0.length because again I'm guaranteed to have a rectangular array in everything I do in class. And so that grid sub 0 length is always valid for a rectangular array. And then col plus plus, and systemout.println passing it current value is, and then grid sub row sub col. So I'll get every value inside that array, what's inside that I'm working with. So every value inside the grid, I'll get the row column value of that. We also can go for int row 0, for row is less than grid.length, row plus plus. For int col 0, col is less than grid sub 0.length, col plus plus, the same exact headers for both the for loops. But if I want to assign into it, now I can actually do that because I'm using the nested for loop and I have the actual row column address. I can talk to that intersection or that address of it and I can assign a value to it. So grid sub row sub col equals a random int from 0 up to 1,233. So we can have that right there so we can randomly assign values into each spot in that 2D array, and it's guaranteed not to go out of bounds because I'm doing all of my tests within a valid logic structure. And that's a really cool thing to help with that. We can also use a for each loop to iterate over a 2D array. And this is great if you want to output or evaluate values. You can't, however, replace values with it because you can't modify the structure of a 2D array with the for each loop, so you can't make that happen. But you can call mutator methods on objects. So you can actually update objects all with the same approach with that, because you can call a method on that because that dot operator allows you to modify the internal state. Good stuff for there. And this, however, is row major only because when you're talking about a 2D array, the concept of a column is just a mental construct. It's only something inside our head as a human being. The logical structure of the data structure in Java is there's a row, and there's another row, and there's another row, and all the rows we have down, and then the columns themselves are just the individual sockets inside each row. You can't extract out a column at a time or iterate over the columns using a for each because the column itself is not a structure. Each row is its own structure. So we have a nested for each right here. So we have for int array row in the grid, and then for int value in the row, I can print that value out. Now, if I try to assign into it right here, so for int array row colon grid, for int value colon row, notice that using Eclipse right here, I have that yellow underline of uselessness. So even though I have value equals 7, all I'm doing is I'm assigning the temporary variable value, the value of 7. It's not actually the structure that's inside that array. No, I'm not even getting that. It's just that's like, oh, I just assigned a 7 into a temp variable. It gets deleted right here on this lovely squiggle right here. As soon as I hit that squiggle, value is thrown away and I get a brand new value on that. It's just a temp variable. It's not actually the value inside the array. And so this is something we don't want to do. It'll compile just fine, it'll run just fine, it won't do anything. So don't do this because it doesn't actually change the structure of the array. It doesn't do anything good. Eclipse warns us that it's giving uselessness. We're not actually doing anything with the value. So you want to make sure that you don't assign into with a for each loop because it won't actually do anything. You just wasted code to write that out. So a for each loop is great for iterating over a structure to extract values like this. But we can use a object and call mutator methods to do that. And we'll see that right here. So I have a debug duck array Duckburg is a new debug duck array 5x6, and I'm assigning with a regular for loop. I have to actually put values inside it. And so Duckburg sub row sub call is a new debug duck at row sub row and then row and call is call. Now I'm using a for each loop over here for debug duck colon row inside Duckburg, and then for debug duck current duck inside the row. Int helpfulness is a new random number. Cool, great. And then current duck dot set question count, and pass it that parameter of helpfulness. Oh, cool. I'm updating that duck's internal state. Totally okay to do inside a for each loop. I like it. It's great. And then I can do view.displayMessage, and my name is current duck.getName. I can extract that data out. And if I wanted to, I could also ask for its question count and get that information as well. But I can totally call methods inside a for each loop and actually modify the state, because when I use that dot operator, that goes through and actually modifies the internal state. I'm not replacing a value inside the array, but I'm using a mutator method to call and update that information. So it's a great thing you can do using a for each loop. You can mutate objects using mutator methods, aka setters or updaters, that will allow you to do that. We want to make sure that when we're working with a 2D array, the most important thing, the area that we have the most amount of errors though, is in bounds checking. Bounds checking is when I make sure that whenever I talk to a 2D array, I'm always talking to spots that are valid in that 2D array. So you always want to do your bounds checking first. And so the bounds that you have, every row index is guaranteed to be greater or equal to 0 and less than array name.length. Every column index is guaranteed to be greater or equal to 0 as well, but it's going to be less than array name sub 0.length if we're talking a standard 2D array. So you want to make sure whenever you're doing a manipulation or modification inside a 2D array or accessing spots that are not the actual spot you referenced inside the for loop, that whenever you check anything like that, when you check to see if a spot is valid or something's in there, you check the bounds first. You make sure that that is done beforehand before you do any code with that. Otherwise, you'll get an array index out of bounds exception, your app will crash, you'll burn sad tears, and nothing's happy. So you want to make sure you do all bounds checking before you do this. When you're talking about this, for example, if you're using the Picture Lab project or the SandLab project, you want to make sure you check for the address of what you're looking at first, make sure it's a valid address, and then you go in and check to see if the contents of that spot are available or what you want to work with. So check the address first and then go look, make sure it's a valid address before you go inside that address and look at the contents of it. Very important, very critical to work with. Arrays, again, are still the hipster of Java, so you want to make sure that we have no methods that are available to a 2D array. We can't check to see if it contains something or what the size of it is. All we have is dot length. That's all we know on a 2D array. And so there's no constructor or any parens anywhere inside. So if you ever see parens, you're going to get a compilation error or a syntax error. It's not going to compile because there are no parens that exist inside the 2D array. We have array name.length as a data member for number of rows and array name sub 0.length for number of columns when we're dealing with a 2D rectangular array. That's all we have. And so you make sure you can't actually call a method on that. You have to actually use the stuff that's inside the array, and you can use methods on those, but the array itself doesn't have anything that we can call or work with. Now, we do have a special case called the jagged or ragged array. A jagged or ragged array is a non-rectangular 2D array. It's an array that has random sizes of width on that. And I will never use it in class. I don't see a good use for it. I'd rather use a jagged array list structure where I have my dynamic structures that grow and shrink as necessary. But this is one where it's like, oh, I'm going to have only 1 of this thing, 5 of this thing, 400 of this thing, whatever. And so Traversal cannot use array name sub 0.length for the structure because we can't guarantee that every single row is that amount. We have to actually ask each row for the traversal as we do it because the column counts are independent per row. And so let's take a look at that right here. Here we have a private void jagged demo. Int 2D array jagged is a new int array. Now notice right here we have 5 and then an empty set of square brackets because I haven't defined how many columns exist on each of those rows of that 2D array. Jagged sub 0 is a new int array of 5, jagged sub 1 is a new int array of 1, jagged sub 2 is a new int array of 3, jagged sub 3 is a new int array of 2, and jagged sub 4 is a new int array size 5. And so you can see the example right here with the addresses over on the right-hand side. We have jagged sub 1 sub 0, jagged sub 2 sub 0, jagged sub 2 sub 1, jagged sub 2 sub 2, jagged sub 3 sub 0, jagged sub 3 sub 1. And so you can see the idea that we have a jagged structure, and each of those values are automatically equal to zeros because it's an int array, so the default value on all those are 0 as well. And that's what we do to make a jagged array. Now, if we want to traverse that jagged array, we have it right here. We have a Jagged Traversal demo. And so we made a debug duck array because debug ducks are fun. We have a new jagged array debug ducks. Is a new debug duck. It's 5 nothing again because I don't specify and have to specify each row. So sub 0 has 4 ducks in it. Sub 1 has 1 duck. Sub 2 has 1 duck. Sub 3 has 67 ducks. Why not? And then sub 4 has 2 ducks. Great jagged structure, not very useful. I'm going to use a for loop to iterate over the entire structure to make sure I can assign new ducks each spot, but I don't want to go out of bounds. So my standard for loop using row-based order. So for int row is 0, row is less than jagged ducks.length, row plus plus, standard for loop for there. However, my column loop for int call is equal to 0, calls us in jagged ducks sub row.length. So I ask each row, how many spots do you have first? And then I go over that. So that way I can iterate over that structure. And because, again, I can't assign using a for each loop, I have to use the for loop for that. So jagged duck sub row sub call is a new debug duck, and I pass it its row address to make sure I have that available. However, I can use a for each loop to traverse the debug duck array in a 2D fashion when it's jagged. For a debug duck current row in jagged ducks, then for debug current for a debug duck current duck in the row, I'll display the message of each duck's name. So I can use a for each loop to traverse a jagged array, no problem, because I don't care about the positions. However, if I'm using a 2D array to traverse it using an address-based one, aka a standard for loop, I have to make sure that my inner loop is my column loop, and I use that sub row on that, making sure that each row is valid before I go through that, because I have to make sure I can do the appropriate amount of spaces for that current row when I iterate over that. Hope this is a great tool for you to look at in using 2D arrays. Have a great day. We'll see you next time. Bye-bye.